Okay, good day. So now we are looking at a different part of finance where you need to actually, from your grade 11 now, I think now you know how to calculate your interest, and you also know how to calculate maybe present value. But now when it comes to N, this is actually the first grade of class. Now, let me take you to algebra so that you can understand the concept here between the relationship of logarithms and your exponents. So what we see that this relationship, when you are saying if A is equals to power B and is equal to C, we are saying this is our base. This is our base. This is the exponent, and that one is an exponent or a power. So that one is an exponent, which is your B. Now, what we are saying is that when it comes to log, we say log same base, which is what? Which is C, same base, which is A. Then we take the value, the answer there is going to be equal to our power. Can we see what we are doing here? So we are saying log same base, C must give us the power. So now if we are, let's say you found that it's x2 to the power x is equal to 8. For you to find x, you know that x is going to be equal to log base of 2 and 8. And if you take your calculator, you punch here, this button here, the log, you find that it gives you option for base, then you put your base 2, then when you're giving you option for 8 there, then you put your 8, then you get x equal to 3. And now if you want to check your answer, you can say 2 to the power of 3. What do you get? You still get 8. Okay. So just for you to understand this, make sure don't forget it. Like if we can say 10 to the power of 2 is equal to 100, then we know that 10 to the power of x, sorry, let's put x. Then we say x is going to be equals to log base 10, 100. Then we get what? We get 2. Log base 10, 100. We get 2, like that. So I hope you understand this part here. I hope you understand this and you're able to apply this. You can apply this in what you call geometric series. You apply this now in finance. So you must also understand now how are you going to tackle here. Now let's look at the question. The first question: a small business had a number of computers which originally cost 70,000. The computer were then sold for 30,000. Calculate how long it took the computer to depreciate to 30,000 if the rate of depreciation was 12% per annum, reducing balance depreciation, 12%, per annum, linear depreciation. So what we know, reducing balance depreciation to A, it's A is equals to P1 minus I to the power of N. So we are looking for N here. So what are we given? We are given A. A is 30,000. Okay. Then our P is 70,000. Then our I is 12% per annum is 0.12, which is 12 over 100, 0.12. Then what else do we need there? We are looking for what? For N. So N is the one in equation here. So what do? We take our A is what? 30,000 is equals to 70,000. In bracket 1 minus 0.12. Let me just allow me to rub here. 0.12. Okay. Now to the power of N. Okay. Now what are we getting now? We divide both sides here by 70,000 because we want to get rid of 70,000 that side. 70,000. Then we're going to say 30,000 divided by 70,000. What do we get? We get 0.42. We can even put it as a fraction like that. 3 over 7 is equal to 1 minus 0,12, 1 minus 0,12, we get 0,88, 0,88 to the power of n. Again, guys, you can't multiply 70,000 in this. Whenever you have a power, guys, it remains the base. You can't multiply with anything. We can't say, let's say we are given here. We can't say, if we are saying 2 times 2 to the power of x is equals to 8. We cannot say 2 times 2. We cannot do that. We cannot do that. We can never do that. The 2 remains 2 to the power of x. But what we can do is divide by 2. We divide by 2, we get 4 there. Once we get 4, we can now do what we have done there so that we can get 2. Okay, so please don't multiply, because some of you say 2 times 2, then it's giving 4, then you are now having 4 to the power of x, which is totally wrong. Okay, now let's move on and see what we have here. So now what we're having now is good now. I think now we have got the results that we wanted here. What have we indicated here? What are we going to do now? We know the relationship. We know that n is going to be equals to log. What is our base? 0,88. What is our value there? 3/7. Then what becomes our n there? Let's check. Log 0,88 there, 3/7. Okay. Let's see what we get. We get 6.62, 6.628. 6.628. What is it? It's gonna be what? But now something what we have here is 6.628. We can say 1 goes on like that. But now what we have here is that we're going to have 6 years. But what we have here, we're going to have 6 years. Then what we have now is that months of what? The months we're going to save 0,6281. What do we have after the comma there? Times 12. Because we want to see how many months are we given there if it is 0,64. Like if we can say, for example, for you to understand this, if you maybe get 6,5 years, I think you know that this is 6.5 years. 6.5 years mean that is 6 years, 6 months. But how did you get the 6 months? Can you ask, have you ever not asked yourself? You're going to say it's going to be 6 years, then plus, well, you can say 8 though, but you have got months of 0,5 times 12. Then what do we get? Months. Then what do we get there? 0,5 times 12, you get 6. So it's going to be 6 years, 6 months. I'm doing this for you to understand much better when you're solving your questions. Okay, when you get 6,7 or 6 to what years, remember you need to express it as what years and months. So what are you going to get there? You're going to say 0,6281 times 12. What do we get there? We get 7,5. We get 7,5. Okay. So it's gonna be approximately 6 years. And we are saying this should be what? We wanna see how long it will take to depreciate. So it's actually approximately 8 months. Okay, approximate. Now let's move on and see the next question. 12% per annum linear depreciation. Now linear depreciation, what we have here is that it's B. We have A is equals to P 1 minus IN. Then in this case now we're going to have what? 30,000 is equal to 70,000. 1 minus, what is I? I is 0,12 N. Okay, then what we're going to do, we're going to divide the same way we did here. We're going to get 3/7, but 3/7 that we get here, we're going to say 3/7 minus 1 there. 3/7 minus 1, we take the 1 here, we bring it here, is equals to negative 0,12 N. Then what are we going to get there? We're going to say 3/7 minus 1 we get what? We get negative 4/7. Then we say this answer here divided by negative 0.12. Then what do we get? We get 4.76. So we're going to get 4.761904762. Yes. Then it's gonna be 4 years. Gonna be 4 years. Then in bracket 0.7619190472 times 12. Then what are we going to get there? Then these are months. So we're going to say now, let's just say -4 so that we can get that fraction there that we want, the what is it, the decimal that we want there. We say times 12 there. What do we get? We get 9.14, which is approximately 9 months. So your answer there is going to be 4 years, 9 months. That's our final answer there. Okay. Now let's move on. Find the time taken for a certain sum of money to double if the interest rate is 12% per annum compounded same annually. Okay. Now we are told that find the time taken for a certain sum of money to double if the interest rate is 12% per annum compounded. So what information are you given? You are given I. Wait, just me to wrap here. Let's use the formula that we're going to use here. A is equals to, for it to double, it means that we are using compound interest. It's compounding 1 plus I to the power of n. That's what we have there. So from the formula, what I always like is that tell us what you're given. Write down what you're given. A, this is accumulated amount. Then P, initial amount. Are you given this? Yes, you are given. What is given to you? You call that X because it's not, you are not given a figure, but you can call it X. But you're told that accumulated amount to double. So for this one to double, it will be now 2X. So you've got the accumulated amount, you've got the principal amount. Now, what else do we need now? I is equal to what? I is equal to 0.12, which is a 12%. Then what about n? We want n. So our n there is the one in question, but otherwise the rest we are given. Now what do we do now? We're going to say 2x is equals to x in bracket 1 plus what is our I? 0.12 to the power of what? To the power of n. So now what we are going to do now, remember what we did previously, we're dividing. We divide with the p. So what do we divide with? We divide with x. We divide with x. Then x cancels, x cancels. We are done with x. We no longer worry about x. 1 plus 0.12, we're going to say 2 is going to be equal to 1, 0, sorry, 1,12. 1,12 to the power of n, like that. 1,12 to the power of n. Now, what have we learned now? We have learned that we can finish this easily. Log n is equals to log our base 1,12. What is our figure there? So we come to our calculator, we press log what? 1,12. Then what we have inside there is 2. Then what do we get in what's called as our n? N becomes 6,116255374. I encourage you to write everything that we have on the comma. Yes, so these are years, but we want to find out how many months. So what are we going to do? We know that it's going to be 6 years. Then what else do we have? 0,11. What is it? 6,255,374 times 12. What do we get there? These are your months. Then what are we going to do? For us to remove the 6, we're just going to say -6 there because we don't want the one after a number before the comma there. Now, what do we get now? We say times 1 1, 2 there. What do we get? We get 1,39, which is approximately 1 year. Okay. So this is just rounding off. So it's going to be 6 year, 1 month. Not 1 year, sorry. 6 year, 1 month. That's our answer there. Okay. So we have seen now how we are supposed to do when you want to find the n and the n if your n is actually a power. Okay. Now let's move on to another problem there and see what we can what we are faced with. Now determine how many years it will take for the value of the car to depreciate to 25% of its original if the rate of depreciation based on reducing balance is 15% per annum. Remember, guys, we are saying reducing balance depreciation, A is equals to what? P1 minus IN. Sorry, 1 minus I to the power of what? To the power of, I hope you guys don't make this mistake that I'm making here. Now, 1 minus I to the power of N. Okay, now what else do we need now? What are we given here? We are given what? We are given A, we are given P. So what is our A? We are told that determine how many years it will take for the value of the car to depreciate to 25% of its original. So now what you need to know is that depreciation, the original value is our P. That's our principal value. So what is our principal value? It's X. But we are told what? That this car is going to be reduced to 25% of X. So what is 25% of X? 0.25 X. 0.25 X. So that's what we're given there. 25%. 25% over 100 times X. That's what we mean there. 25 over 100 is 0.25. That's why we're writing it like that. Okay. Now let's, what about I? Our I is given 0, sorry, 16%. 16%. So it's 16 over 100, which is 0.16. That's our percentage there, our interest. What about our N? The one in question. Our N is the one in question. So what must we do now? We write our formula. 0.25x is equal to X. Remember, principal value is actually bigger than an accumulated amount, because this thing is depreciating, it's losing value. Depreciation, losing value. When it's losing value, it means that the accumulated amount, the future amount, is actually less than the original amount. Now, what do we have there in bracket? 1 minus, what is our I? 0.16 to the power of what? Our N. Now, how do we remove the X here? Remember, we divide by X, then we cancel that. Then we are left with what? 0.25. Now 0.25, we're going to say 1 minus 0.16. What do we get? We get 0.84. So this is going to be 0.84 to the power of N. Can you see that? How beautiful it is. Now what do we do? N is going to be equals to, we now know our story. Log 0.84. What is it? 0.25. Then what do we do? Log 0.84. What do we have inside there? 0.25. What do we get there? 7.95. So 7.95. So here I didn't read the question. We are looking for N. Calculate the annual rate of depreciation. Oh, sorry. Where am I reading now? Now it's fine. We are still in the same story here. Sorry about that. Then we're going to say 7.951060,681 years, which is going to be 7 years. What about month? 0.9510681 times 12. We put that in brackets. Then we're going to say minus 7 there. What do we get there? We say times 12. What do we get? We get 11.4, which is approximately 11 months. So it's 7 years. Four months. 11 months, sorry. 11 months. We don't need to put days, okay? We don't need to put days. Sorry about that. We don't need to put days. So it's going to be approximately 11 months. Okay. Approximately 11 months. So it's 7 years, 11 months. Now let's go on to the next part there and see what we're given. Now, calculate the annual rate of, a car costs 300,000 and it depreciates over a period of 5 years to half its original price. Okay. Now, calculate the annual rate of depreciation if it is based on the reducing balance method. Now, what are we going to do? We're going to say A, reducing balance. A is going to be equal to what? P1 minus I to the power of N. What is given to us? Period of 5 years. Okay, original value. Now, a car costs this. What is our A? Our A. Do we have the A there? Okay. To half its original. Okay. So we have got P is our original 300,000. What about our A? Half of its original, which is going to be 300,000 divided by 2, which is going to be 150,000. Okay. Then what is our what else do we need there? Our N. Our N is going to be equal to what? Our N, this is annual. Our N is 5. Okay. What is our I? We are looking for I. So we are looking for the what? We are looking for the interest, annual interest rate of depreciation. So we're looking for the, so we're going to say our A is what? Is our A is 150,000. Okay. Is equal to 300,000. Okay, 1 minus I, we are not given. Then what do we have there? We have got N, which is 5, the power of 5. Then we divide here. When you divide here, you're going to divide it by 300,000. By 300,000. Then that's 3 million there. We don't want too much money there. Okay. Now, what are we going to get there? We cancel that. Then this one give us 0.5. Now we've got 0.5 is equal to 1 minus I to the power of what? To the power of 5. 1 minus I to the power of 5. Now, what do we do when we're given that? We want to get rid of that 5. We want to take it that side. What are we going to do now? What are we going to do? We know that we're going to say we remove the power. I'm gonna show you again something here. I've done it in, I think in finance 1, should be finance 3. Now here what we have here, if we have got x to the power n is equals to 5. For you to get your x, you will say x is going to be equal to, you put the root sign, our n is there, and we've got our 5 there. That's what we do. Okay, I think I've explained it. I explained it clearly where it's coming from on the lecture. What is it? I'm going to explain also here if I have space here. Now, what we have here, we're going to say 1 minus I is going to be equals to fifth root of 0.5. Okay, then what do we get there? So we come here and punch our shift. Okay. Oh, no. Where is our shift here? Where is empty here? Then you can write 5 there. We can write any number there. Okay. Then we have 0.5. Then what do we get there? We get 0.877. Now, if we've got that and we can take it there, we subtract by 1. So we're going to 1 minus I is equals to 1 minus 0.870555056, goes on like that. So you're gonna say this one here. So our answer, I'm gonna say 1 minus our answer, we get what? 0.129449, what? It goes on like that. Then our I, we remember what we do, we just times by what? By 100. We say by 100, then we're gonna get I equals to 12.9 12.94%. So that's our value there, 12.94%. Then how long will it then take for the car to depreciate once again to half of its value? Assume the depreciation rate is the same in what? What is it? In A. Now remember here we're looking for A, N. So what are we going to do? We're going to say on our B, this was our A. Our B there, we know that we are given what? We are told that A is equals to P, 1 minus I of N, okay? Then what is given to us? We are told that to reduce to its half of its, how long will it take? How long will it take for the car to depreciate once again to half of its value? Half of its value, remember guys, whenever we're saying half of its value, we can even use X here. We can use what we want, isn't it? What we just mean is that if we have got, 150,000 here as our principal, 150,000, our A will be 75,000. Then our N is the one that we want. Then our I is what? 12.94%. Now here, and if you have a question like this in the exam, I think it's good that whatever percent that you get, you carry on if you have the idea to get the second one, okay? Now, then what we have there, we have got, we're going to say our A is what? 75,000 is equals to 150,000. I could make this one short, but I just want you to see how it's done. 1 minus I, what is our I? 0, what is it? 1294, okay, to the power of N, okay? Now, what do we do here? If we divide both sides here, 150,000, 150,000, what we get there is half, which is 0.5. 0.5 is equals to 1 minus 0.1. So we're gonna say 1 minus our answer. What do we get? We get 0.87. So it's 0.87 to the power of N. Then here, what do we do now again? Remember, N is equals to log 0.87, same base, 0.5. Okay, so we're gonna say log 0.87. Then you have got 0.15. No. 0.5. What do we get there? We get 4.977. 4.97. Let me put it here so that you can see. But remember what you do, you write everything there. 286,305. Now, what do we know now? It's going to be 4 years. 0.977286305 times 12. And what is this? These are months. Then you're going to say minus 4 there. Then you say times 12. Then you get what? 11.7. 11.7, which is what? So 11.7 is approximately 12 months. So it means that this is approximately 5 years. This is approximately 5 years because we're getting 11.7. 11.7 is approximately 12 months. So 12 months is a year. So it's going to be, 5 years. Okay. It's going to be 5 years in that case. Okay. I think I'll cut this one here. Thank you so much. I hope you guys won't have any challenges when you're calculating N. You won't forget the relationship between your log and your, and your exponents. Okay.